Our next presentation is from the Allotrope Modeling Working Group in conjunction with Dow, and is around an update on the working group with some recent activity and development, how they're modeling new techniques using Excel. So a short overview of how simple and how easy it is to model a new technique. And then the second half of the talk, we'll be talking a lot about the work at Dow on developing the models and using the data, using these different models. Traditionally, Allotrope has worked mostly in the biotechnology and pharmaceutical domains, but with Dow, we've had a lot of great work going on in the chemical domain now for the last few years, and so I think it's great to hear about how things are being used there as well. And so today's presenters will be Amnon Potashik, who most of you know. He's the technical director for Allotrope, Ben Wolford Lim, who is Allotrope senior developer, Simon Cook, who's a solution manager at Dow, Leo Musters, who is who's basically our subject matter expert for LIMS, and also an Allotrope board member, or a former board member. And then lastly, Vasily Dulsky, who is from Dow in informatics there. So why don't we go ahead and take it away?
Hi, everybody. We are going to present some update of the work that is done within the modeling working group, especially for the recent quarters. We were developing some models together with Dow SMEs. We will discuss statistical feature, aggregation pattern, and converter implementation by Dow. So first of all, it is important to understand that it's not only one company, one chemical company, one pharma company, one organization. It's a team effort. And this is what Allotrope is all about. It's a team effort. It's a community collaboration, whether you are an instrument or solution provider, academia, or a research institute. We are around the table. We are sitting with scientists, technologists, ontologists, modelers, data scientists. We are all coming together trying to solve the tough interoperability challenge. So today we'll discuss the path for modeling a new technique. We'll discuss some of the tools to generate the model using the basic Excel spreadsheet. We will give an overview of statistical features and then data science in the chemical industry, Dow developed model, statistical aggregation example, and aggregation patterns, and then the Dow converter implementation. So the modeling working group follows a very streamlined and a collaborative process for developing new tabular models and of course, the supporting ontologies. And this slide set, it presents some kind of phases from the day that an organization is sponsoring the model all the way to a release and having the model in one of the repositories. We start with, as I said, with a sponsor organization. We have the scientific SME from this organization capture the ontology terms. We identified together with the semantic tools and the semantic SME, we identified the existing term within the AFO. Those that are missing, we define new terms. And it is very important to mention that we are not define new terms just per se for the ontology definition. We are very much model and use case driven. So new terms are model and use case driven. And then we draft the model using the Excel template. And it goes into an iterative review process of several reviews and term definitions. And then once the model is ready, it's finalized. One step in between is to share a sample file with a sample data file and to plug it into the Excel template. So the Excel template includes the model, the terms, and the instance data of real sample data file. Once it is finalized, it goes into the submission or to governance. And this is where the product team takes it from the modeling work that was done by the scientific SME, the semantic SME, into the governance process, which is wholly owned by the product team. We have tools that are related to the governance, automation tools that we'll see in a moment. And then once every quarter we release, we are trying to automate it as much as possible. And the release of the models is done usually to the JFrog Artifactory, the community, the Client Connect repository, and into the GitLab CI platform, the relevant folders. This is the slide that describes the governance process and the tools that we are using from the moment the model is ready for governance all the way to release. So as I described earlier, the modeling working group is defining the model and using a sample data, using the Excel template. Once the Excel template is ready, it is plugged into a tool chain that generates first of all, the Allotrope data model using the shackle format. Secondly, an instance data, an RDF turtle format instance data. And third, a sample data instance ADF file. The sample data instance is just for the data description. Those three files are going into the new tool chain that was developed a year ago to transform from the RDF or the shackle into the equivalent JSON format, which is JSON schema. So transformation between shackle, RDF shackle to JSON schema, that gives us the first transformation, and the second transformation is between the instance data that is RDF based into a JSON text-based format. So now, after those two are generated, we have the ADM, the ASM, we have the sample instance data of RDF using turtle syntax, we have the ADF file, and we have the JSON data instance. And now using the platform, the GitLab platform and the CI tools, and part of it is automated, and we are working on automating it more and more. We are distributing those files into the different repositories, which are typically the GitLab, the JFrog Artifactory, and the Client Connect community repository. So practically, in order to start modeling a new technique, the scientific SME and the sponsor organization has to work on an Excel spreadsheet. So modeling with Excel spreadsheet, the Excel template that we have is very simple and intuitive. And we have a new step-by-step guide to a tabular model creation using Excel. It's a Word document, and it is available for download from Client Connect within the modeling working group folder. And the folder link is available at the Wednesday invite modeling working group Wednesday meeting. In addition, for those that wants to see a video, we have aggregation model tutorial, and it's include a modeling walkthrough and a demonstration of how to develop an aggregation model using the Excel template. And from this point, I'm transferring the presentation to Ben to discuss statistical features.
Amnon, thank you for the intro. Yeah, so from the how the modeling working group works to some of the stuff that we've done in the last 2 quarters or so, as well as a range of new models, which I think Vas will list, or possibly Leo will list. I know it's listed somewhere later in the platform, later in the talk. We also have come up with a new structure for statistical features. And So this is explaining the motivation behind it. Originally, when we recorded statistics in the tabular models, we treated them just as new terms that needed to be minted. So we'd create a term for average temperature, another term for maximum pressure, another for minimum velocity, and so on. Whilst this worked early on in the process for small numbers of terms, some of the new models coming out, particularly the one or two from the Dow team, showed that it very quickly gets impractical once you start using a lot more statistical terms like this. So if you have to create minimum, maximum, and arithmetic mean for every measured quality that you want to consider, it significantly bloats the ontology. You have to do it for temperature, for pressure, for velocity, for length, height, and so on and so forth. Three terms, just those three terms for each of those suddenly explodes very quickly, and that's before you take into account things like the median, the mode, standard deviation, things that are still quite common, quite useful, but maybe not quite as common. We determined that a new approach was required to ensure that we could maintain a sustainable ontology and represent this information in a uniform but standardized manner. So you can see down the bottom there, if we were doing it in the original way, those for just pressure and temperature, those three things, you'd have to mint those 6 red terms in the screen there, and that just explodes very, very quickly. So if I can, yep, okay. So in a first pass approach earlier in the year, we attempted to reuse our existing document pattern to create a statistics document. That was intended to basically collect up the statistical feature, which is the thing we were measuring, the quality, temperature, pressure, along with the statistic concept, the maximum value, the minimum value. So for the first pass, this worked in a semantic sense, but we found on the implementation side that it had quite a few limitations. One of which was the original approach meant that the value in units ended up linked to that statistical term, so arithmetic mean or maximum value, instead of the quality being measured, temperature or pressure. As a result, because of the way the shapes for the ADM and the ASM work, we could no longer actually specify a specific unit, because arithmetic mean for temperature doesn't have the same unit as arithmetic mean for pressure or for velocity. You have this problem that when the key is hooked to that, when the unit is hooked to that specific key, you can't restrict it because that key might be used in other places. So we had that problem, which was a significant concern. The other issue that was raised, again, particularly from our Dow colleagues, was that the representation for these statistical constructs was actually quite a lot different to a standard temperature has a value in a unit. Now we have arithmetic mean that has a value in unit, and you've got to look somewhere else to find that it's at temperature. It was different enough that it had to be implemented quite differently in software, which added a certain amount of challenge to working with that approach. We also found that it interacted differently with other modeling patterns that we had. So when we had other constructs that required extra information. So I think the example we had was a chord modulus, where you have to specify at a certain strain. We had a pattern to represent that, but when you then combine that with a statistic, it became confusing as to which approach you might use. So we tried this as an initial approach. We found that this didn't work in the earlier version of those models. So as a result, we've refreshed it. We've gone through a few iterations, and the latest approach that we have opted to take is to extend the core leaf node pattern of this value and unit, which any of you who have used our tabular graph or simple models will have seen at some point. We're opting to extend this to allow an optional third attribute, which will be the statistical role. So as a result, the statistics then become members of a statistics document, so we can collect all the related statistics together. If you have a minimum, a mean, a maximum, they all live under the same statistics document, and then each of them has an individual third attribute saying this one's the mean, this one's the maximum, this one's the minimum. Using this approach, we basically maintain compatibility with the original representation. It's still a temperature, it still has a value in a unit, it just has an extra flag to say whether it's a statistic or not. because we're now representing it as a temperature with a value in unit, a pressure with a value in unit, we can now retain control of those units as well. So we can again say that an average temperature still has to have units of degrees Celsius or Kelvin. An average pressure has to have units of pascals or whatever. It still maintains our full semantic correctness, just as the previous approach did. And it's also entirely compatible with JSON representations for ASM. The translation process and some of the restrictions on JSON mean that we have to be a little bit careful sometimes when proposing things that would be valid under the RDF or the semantic approach and may not translate nicely into a JSON representation. This approach works fine, and we have translation planned for it, so that's good. The caveats to this, and there's always a downside, is as a result of this change to the core value unit pattern, we now have to update the tabular model queries, which have been stable for the last 2 years, I believe. They'll need a small refresh to pick up this new optional statistical role attribute. So as a result, any software leveraging those tabular model queries should ideally update to be able to read new future models using this approach. Likewise, and then tying back into Amnon's mention of the toolchain, that tabular model Excel template that we've been using successfully for the last few years, we'll need to do a small update to that to add a column for the statistical role. So you can say this value is an average versus this value is a maximum, or this is just a regular value, and we'll have to update our tooling to allow for that. So there's a new pattern, a new approach. As a result, we've got a little bit of updating to be done with our toolchain, but the strength is that it allows us to represent this in a clear and consistent manner without having to mint 5 million terms for every possible statistic under the sun. So this is a fairly significant change and a fairly significant update out of the modeling working group. So I count this almost more than the new models as a significant success of being able to come up, iterate with, and find a new approach that works both in a semantic, an implementation, and also just a pragmatic maintenance sense. So I think from there it's over to Simon, I believe.
Thanks, Ben. And Leo asked me to talk a little bit about why we're doing all this work on the Allotrope data model section. And we like to think of it as kind of like a pyramid, where a lot of companies talk about how you do data analytics, how you do modeling, how you do, and I'm trying to steer away from the buzzwords here, how you do calculations to predict properties. And the real reason is we want to get products out to our customers as fast as we possibly can with the best employee experience and the best customer loyalty. And a lot of that comes down to how do you gain insight from your data. A lot of it's through analytics and visualization, which can be as simple as plotting everything on a graph. But we're actually going a step further, and this is a really easy example, but just by changing colors, changing symbols, displaying your graphs in different ways, you're going to get different insights from it. So it's really how do we make the step from the basic graphs of the past, basic being a relative term as to where you are in the journey, to a much more expressive graph that really tells you something, as opposed to, hey, I got a lot of data here. And then from a modeling perspective, we want to deploy these so that instead of Simon has to go in the lab, grab some data, calculate it in Excel. No, that's going to take far too long. We want to automate all of that kind of stuff. And it's really using machine algorithms to really do this for us and to put that into the data domain. Well, to do that, we need to feed that data. And that data comes from things like molecular modeling, different digital material science initiatives, different formulation data. And then in the middle, we've got this term comprehensive digitalization. And what that really means is it's a summary of the 3 boxes underneath. We've got to get our data off the instruments. We've got to be able to explore that data and clean it up. I would love to say that every piece of data coming from our labs is completely clean and able to be used from day one, but that would not be true. But that's our vision. Once we have that cleaned data, then we can automate a lot of this process. And some of that work that Leo will expound upon later is really around how do we grab that data, how do we look at the data and transform it into these different models, and then once we have that data, how do we find the data? And I would not underestimate this data culture box at the base of the pyramid. That is absolutely critical, and changing people's culture is tough. So this is really a long-term strategy. How do you change the scientists in your company so that they exhibit the behaviors that puts the data in the right place with the right file name, with the right context data, with the right information that you need to link it all up to be able to make these models work. And that's really a lot around what our data science initiative is working on within DAO at the moment. I think I hand off to Leo right now.
Thank you, Simon. So what we did do together with the modeling group, and it was an excellent collaboration, is we launched a couple of models specifically for DAO instrumentation and methods we done. You can read it on the slide here: tensile, foam height, foam quantitation, gloss, and HOTEC. You're specific for characterization of materials. And we do have another set of methods we do want to include on our roadmap for next year. These are some highlights. Just as work, we have tons and tons of instruments which are on our to-do list, and we also have tons and tons of methods. So we have to pick and choose where we can have the most gains on here. But we have seen from this whole process that with the, like I said, with the collaboration of the modeling with Ben, that if you do the preparations upfront, very good. So you filled in as a pre-work, homework, your Excel templates that the modeling group provides. You do a lot of talking with the instrument SMEs or the scientists already to do predefine the fields that you want to have include in the model. This whole process can go pretty smooth, and that we definitely highlight that the things that the statistical new features that we introduced in the models was an excellent example on how it actually is a collaboration effort and not a one-way dictation of a company dictating how everything wants to move. I think we can go to the next slide that is going to be for us.
All right, hello everybody. I was hired by DAO to develop a converter for take the instrument files that are already parsed and are in our equivalent of the independent results format at Merck, where we first parse instrument files into like a common format, and then from there we submit we pipe the data down to LIMS, which is existing workflow at DAO, and then also into the Allotrope. So I was hired by DAO to implement the piece of software that would take that independent parse data and package it into the Allotrope format. So from my perspective, developing the converter, and I was also responsible for curating some of the DAO models, interfacing with Allotrope modeling group. So I have two slides for this presentation, which kind of represent my two observations and efforts as it related to this project. So the first one is follow up on Ben's point about this slide is just simply to illustrate our journey trying to design these aggregation patterns. And by aggregation patterns, I mean the connections of the actual graphs representing, values. This one, we chose a statistics aggregation pattern as an example of, a journey from one iteration of this graph to another, finally settling on this yellow graph representation that Ben already described in great detail previously. So I don't really have anything to add. I just wanted to present this slide as a illustration of a point of view from a consumer of Allotrope models, of how we had to sort of go through this iterative design to come up with the aggregation pattern that we that is both semantically correct and fits into the Allotrope framework, and also is easier for us as a consumer to use. So this slide is supposed to represent that. The other observation or experience I wanted to mention is on the next slide. Yes, thank you. Okay, so this slide pictures two different DAO models in this graphical format, and then the third picture here is kind of an example of another aggregation pattern that is specific to gloss model. So the aggregation pattern here is in the middle of the screen on the right side, specular reflection aggregate document, for example. So this portion is an example of a model specific graph, whereas the two on the left and the center also come from different models, but they illustrate sort of a common structure between the DAO models that has been another effort on our part to accommodate consumption of Allotrope files by the various analytics softwares that Simon described. We decided to kind of standardize our models a little bit, in the sense that they would all start, for example, with a measurement aggregate document, which roughly translates into DAO's sample or sample test combination in laboratory datum, so to speak. So each of our Allotrope files and the models, which we use as templates, will contain a single measurement aggregate document. For example, we want to represent, the sample and test and other metadata and things like that. And then each test would be represented by a measurement document, for example. And then you see the two examples of device system and device control aggregate. Again, that's just to illustrate that the models that we've developed for DAO will have a slight underlying structure, common to some models. For example, here we can see the device system is present in both models. Okay, so just a final note on the converter, just from a perspective of a designer. For the Allotrope converter, which is pictured here, it's implemented as a Java, which is native API for Allotrope Java function within Azure. And I will let Leo cover this whole pipeline, but for the Allotrope converter piece, which I'm responsible for, I just wanted to make the two statements about the two slides, one for the aggregation patterns and how we work with Allotrope on that, and also the sort of larger structure imparted to all of our files. I think that's it for me, and I will hand it off to Leo. Thank you very much.
Yep. Well, thank you, Vas. So before we go into the converter itself that has been designed and being implemented as we speak by Vas and the whole team that are, the converter is basically part of a creator initiative that we have within DAO. So it's part of what we call what I'm leading here is the Unified Data Acquisition Framework. And the slide you see over here is actually nothing else. It's also common knowledge, what a lot of companies are trying to do. It has a lot of similarities what we have in work, but it just shows you on how it actually, the converter is implemented in a creator framework. So what we actually are doing, let's see if this is actually going to work. Yep. So what we are doing is, as we have a lot of file-based instruments, also a huge amount of instruments. We collect the data from the instruments, and once we basically move that data to landing zones, specific areas, we are doing some pre-processing and validation. So as we are within DAO, we are having a eye on different systems of records. Data coming into DAO is most of, I think, 90% linked to a system of records like LIMS or ELN with its own unique unique IDs. And so what we're doing here in the initial step is making sure those IDs supplied in the results from the instrumentations are valid. So we have built a process in there, and this initial process will make sure we only are processing data which is validated with unique identifiers from our systems of records. The system that's not there, if we are processing data which does not have any of that data, it will not go into the pre-processing. And this leads back to one little comment that Simon made. It's about the culture, which is huge important. If any tools in place in there, that there has to be a certain culture in place to enable this work. So once we actually have done this, we have collected the data, which we know it's valid. We are actually moving it to our cloud storage, and we're moving it to also a scientific data management system in there. We do this at the same time. Once we have moved it to our cloud storage, basically the rest of the processing will happen. So we extract data that's necessary for in the data model. The data models we have, so we have the instrument files, we extract the data that needs to go into the data files, and we send that over to the Allotrope converter, which Vas is going to show you a little bit how it actually is working. So the whole orchestration and processing that we have up as in the cloud will also at the same time move the data to our LIMS or any system of reference. So we combined everything. That's a key difference. So we don't have two separate processes in place where we have one pipeline that goes into a system of records for LIMS and another pipeline that converts the data. We are grabbing the data all together, validated data, and then we are processing the data that goes to this converter, at the same time goes to our system of records. Once the data has been converted, it will also send that specific data, that Allotrope data file, to our SDMS system, where it will be used in a further analysis or further down the line in the pyramid, the same slide as Simon has shown. So this is just show you an example of how the Allotrope converter works and where it fits in the greater need within the DAO world. And I think then now we'll release control, and I think then we can go back to Vas doing the actual data converter.
Okay, so this slide illustrates roughly the converter design, which the processing steps within the converter closely mimic the Allotrope data format, since this is the final sort of product coming out of the converter. So basic design is we also have a template, which is looked up by template, which is a file, which is a model published by an official Allotrope release. We use that model as a template. So each instrument file, once it's gotten to a converter, the data already there is metadata already present, indicating which EDF, which Allotrope file to create, which template to use, and along with the parameters. So the converter simply grabs the template, grabs the instrument file that's already parsed. It's already in sort of a converter-friendly format, and then it combines the template, the pre-existing structure, meaning pre-existing structure, like the file will have only one measurement aggregate document, the sample ID will be here, the common patterns within our models. And then for the uncommon patterns that are unknown to the converter, the template comes in. So I would look up find the base of the graph that's uncommon in the template and recreate that graph in a new Allotrope file. So this slide is sort of just kind of like a snapshot of like the design pattern for the converter, which basically follows the Allotrope file format steps to build the file. The model, the data cubes, the data packaging. That's really all. This slide is designed to be like a high-level overview of the converted design. So far, the converted design is only 1,000 lines. Our philosophy is to keep the converter itself very sort of simple. So that's basically it for the converter slide. Thank you very much.
Great. Thanks, Vas, and thanks to Leo and all the rest of our presenters for a great presentation.